Okay, now let's do the textbook question, section 1.2, question 9. Okay, now let's have a look at the question first. Okay, now here. Okay, question 9. Okay, if we look at the question, we need to use the chart figure 1.14 to answer this. List question A. List all the stable nuclei of calcium. Okay, now we need the stable one. Atomic number 20, calcium 20. Okay, then let's go back to figure 1.14. Okay, on the page 11 of your textbook, okay, there's a figure 1.14. Okay, so if you look at the figure, let me just enlarge it. Okay, I have number of atomic number down below, number of protons, and I have number of neutrons here. Each dot here indicates an asymptote. Whether they are stable or not, look at the key. If it's a square, it's stable. Just let me enlarge it. If it's a square, it means stable. Otherwise, minus means beta, well, they're not stable. They emit some sort of radiation. Okay. However, we're only interested in calcium, atomic number of 20. Let's have a look. Atomic number of 20 here, and if we look at this, okay, now, right, let me just indicate it here. That's your atomic number. Atomic number. Now, this axis here tells me the number of neutrons. Okay, so for atomic number 20, okay, I have 1 square, 2, 3, 4, 5, 6. 6 squares. It means we have 6 stable isotopes. Okay, so let's read. Okay, stable isotope number 1, okay, has 20 number of 20 neutrons. So isotope number 1, okay, has a atomic number of 20. Okay, the mass number will be 20, the number of protons plus the number of neutrons, which is 40. Okay, now then isotope number 2, okay, just give me yeah, something wrong here. This one, okay, if you read on the vertical scale, okay, this is 20, 21, 22. So this must be 22. We have 22 number of neutrons. So 20 protons, 22 neutrons gives me 42. A mass number 42. Okay. Now, then look at the third one. So that's 22. This one should be 23. Okay. Sorry, I made the previous. Yep. So 23. Okay, the third one. So I have 20, 43. Okay. Now let's look at this one. 24. 24 neutrons. Okay. So Ca 20, 44. Okay. The next one, atomic number 20. So number of neutrons will be 26. Okay. We have 24 here, 25. this isotope is not stable. Okay, this one is because it's labeled in square. It's 26, so mass number 46. Then we look up. Now this one will be 28. Okay, the last one, the last square on the top. Okay, 28. Now, it has 28 neutrons. We have 20 protons, 28 of neutrons. Altogether, it will be 48 mass number. Okay, done. Question A. Then let's look at question B. Okay. Now, how many stable nuclei does nobinium, okay, atomic number 41 have? Then let's go back to our chart. Okay, 41. So I need to enlarge it. So if I go there, it's really hard to read. Okay, so basically we have 40 here. 41 should be this line down there. Okay, so just let me write down this. Okay, so I believe it's NO. Okay, 41. Oh, sorry guys, I need to just have a look at the question again. Niobium. The chemical symbol should be N1, I think. Ni or Nb. I need to check it up, but leave it now. Just let me have a look. And yep. Well, okay, let me get a periodic table. Okay. I need to find okay, MB, yes. Okay, I'm right. With 41, atomic number 41. Then we go back to the chart. Let's enlarge it. Okay, now if we look, okay, this line should be 40. Okay, so this vertical line is 40. We're not interested in 40. We're interested in 41. So this line must be 41. Okay, so have a look. How many stable asymptotes does it have? Okay, just let me enlarge it. Hopefully you all can say no. Okay, on the 41 vertical line, we only have one square. It means we only have one isotope here. Okay, now we're only interested in this one. Let's mark it. Okay, now this is a stable isotope. Let's use a ruler, write a line. Find out what is how many neutrons does it have. Okay, it should. The line of 50, that's 50, 51, 52. We have 52 neutrons. Okay, so we have 41 protons, 52 neutrons. Okay. the mass number will be 41 plus 52, 93. Actually, yep, 93. Okay, so this is the stable isotope of niobium. Okay, string. Yep. Now, let's go to question C, the next question. Okay, now potassium 48 has a large imbalance of neutrons over protons and also is radioactive. Find potassium 48 on the chart and determine whether it's an alpha or beta emitter. Okay, now atomic number 19. Okay, let me write it down. Okay, we need to find 48, potassium 48. Okay, so yep, here. Okay. Atomic number of 19. Yeah, it's in this column. Yep, that's good. Now, okay, this should be the line. That's 20 here. This should be the line of atomic number 19. Okay. Now we have 48 mass number. Sorry, the mass number is 48. Okay, take away the atomic number. So it's 29. Okay, this is the number of neutrons. So number of neutrons will be 29. So I have 20. Yeah, I have 30 here. 29 should be this one. Okay, with a minus sign. So let's go to the chart. The keys. Okay, so it's beta emitter. Okay, so potassium 48 is a beta minus emitter. It emits beta particles. Okay, so in this question, we're basically reading the chart. Okay. Now, question D. Write down the decay equation for potassium 48 and determine whether it's dangerous nuclear itself or stable. Is itself stable. Okay. Sorry, or radioactive. Now let's have a look. For potassium 48, it emits a beta minus. Okay, it's radioactive. Now, I don't think we did that in classroom. What's the question? Sorry. Yep. Now, it's a beta emitter, so let me just do the question here. Okay, so potassium 48 emits a beta particle. Okay, it emits a beta particle. Just remember, and this anti-neutron when writing beta particle. Now, so let's balance the equation. We need to write down something here. Okay, the atomic number must be 20. 20 minus 1 give me a 19. Okay, and the mass number should be the same, 48. Okay, so 48 atomic number of 20 should be calcium. if you look at your periodic table, okay, calcium has an atomic number of 20, so that's an equation. Okay. And we have to have a look. Okay, about calcium 48. Okay, and the calcium 48 is stable, so the resultant is stable. Okay. This is stable. Okay, that's what we do. Now, question that's D. Okay, now let's do question E.